Hey everyone, thank you for coming to this talk. My name is Leo Jadnovsky and I'm a Principal Solutions Architect at AWS. I'm going to be talking to you today about orchestrating complex deployments using AWS Developer Tools. Specifically, we're going to talk about what AWS CodePipeline is and what AWS Step Functions is, and how these two services can work together to help you orchestrate complex deployments. So we'll talk about different scenarios for orchestrating such deployments, and we'll do a live demo of one such scenario, then we'll do some Q&A, and we'll talk about next steps if you want to learn more. So first, let's do a quick overview of AWS CodePipeline and AWS Step Functions. Transitioning to the cloud can be a big learning curve, and having access to familiar tools in preferred languages can make for a smooth journey. And our users tell us that they want it to be easy for their development teams to move to the cloud and deliver with AWS, and they also want tools that help them adopt modern application development techniques so they can get the most out of the cloud. There are two major questions from our customers which have guided how we build our developer tools. So the first is a comprehensive set of enterprise-grade tools. That's what our customers want. And our tools have broad language support and are built for enterprise use. In fact, many of these tools are built from internal development practices that we use at Amazon. And the tools are built to support anywhere from small organizations to large enterprises such as Amazon. Our tools are also purpose-built for modern application development techniques. And our customers want to know how to deliver faster, how to reduce errors, how to adopt serverless or containers, and how to focus more on things that matter. So we've built tools that have this vision in mind. And again, we have small startups and some of the largest enterprises using our developer tools on a daily basis. So this slide is a bit of a eye chart, right? But believe it or not, there's dozens of tools that actually aren't on this slide. And so we have a large portfolio of developer kind of related tools. So just to summarize, on the top left, we've got our CI/CD tools. And these are purpose-built for CI/CD on AWS, and they include integrations for EC2, for Elastic Beanstalk, for Lambda, and for containers, to name a few. We also have infrastructure as code solutions that allow you to define your applications and architectures in code in ways that make entire organizations more productive. We have an IDE, Cloud9, which is a cloud-based IDE. And we have 9 different language SDKs to help your developers interact with AWS programmatically in the language of their choice. And we also have our own distribution of Java, or OpenJDK for free, called Amazon Corretto. We also have tools for mobile, for hosting web applications, and for monitoring. And then finally, in the top right, we have listed our monitoring tools, such as AWS X-Ray and CloudWatch. So let's focus in on the actual developer tools for CI/CD. We've got AWS Code Commit, which is a fully managed source code repository, or version control service for private Git repos. We've got AWS Code Build, which is a managed continuous integration service. We've got Code Deploy, and this automates deployments to EC2, Elastic Beanstalk, Lambda, containers, as well as on-premise servers, if you wanted to. And we've got CodePipeline, which is our continuous delivery service for orchestrating your release process. So CodePipeline, again, is a continuous delivery service for fast and reliable application updates. It allows you to model and visualize your software release process, and I'll show you what that means in a second. It allows you to integrate builds, tests, and deploys into this pipeline, and you can set up so they basically they happen the same exact way every single time there's a code change. It also has integrations with third-party tools and AWS services. So I'll be showing you in my demo how it integrates with AWS Step Functions, for example. So let's talk about the supported sources for CodePipeline. So these are things that kick off your pipeline. You can either do a bunch of different Git services, so Code Commit, GitHub, GitHub Enterprise, Bitbucket, or you can use an object or a container image to kick off your build. So you can have an object, for example, like a zip file with your source code in S3, or you can have a container image that goes into your ECR repo, and that can kick off your CI/CD pipeline. It also supports a bunch of targets. For EC2, you can use code deploy, you can use Elastic Beanstalk, you can use OpsWorks stacks. For containers, it supports, again, code deploy, ECS with blue-green deployment patterns, and Fargate. And if you're deploying to serverless, it also supports doing that through code deploy, through CloudFormation and SAM, which is a serverless application model, and through Lambda and Step Functions as well. So let's talk about Step Functions now. So we have a service called Step Functions, and you can think of this service as a fully managed state machine in the cloud. So it lets you coordinate multiple AWS services into serverless workflows so you can build and update apps quickly. So with Step Functions, you can design and run workflows that stitch together services such as AWS Lambda, Fargate, SageMaker into feature-rich applications. And you can write resilient workflows with built-in error handling and retry support. And Step Functions can also provide you with an auditable execution history with visual monitoring for your state machine executions so you can trace and debug when needed. So in this example, why would I use a step function with my CodePipeline, right? So one thing to think about here is CodePipeline supports custom actions. So you can kick off a Lambda function with a custom action in your CodePipeline. However, Lambda functions are typically, any one given Lambda function is pretty simple, right? But what if I want to do something complicated? So what if I, for example, want to trigger a load test as part of my CI/CD pipeline? Well, you can set up a step function state machine that will trigger load tests that run in something like Fargate. So they're running in containers, and you can orchestrate the completion of all those tasks in Fargate, and then collect the results, and then send those results back to your pipeline. So you can see if the load test was successful, your pipeline moves on to the next stage, and if it's not successful, it stops. So for something complicated like that, step functions is perfect. So let's talk more about how step functions work. So each workflow in Step Functions you build is represented as a state machine. And then each step in your workflow is called a state. When the step function executes, it moves from one state to another state, and that's called a transition. And a cool thing about Step Functions is that by splitting up your workflow into discrete steps, you can reuse those steps among multiple state machines, and even easily view and edit the sequence of the steps as your needs change. So each step function is defined by a JSON document that conforms to a specification described by the Amazon States language, which is a JSON-based structured language used to define your state machine as a collection of states that can do work. So for example, like task states. And you can determine which states transition to the next, like choice states. And you can also stop an execution with an error, like a fail state, and so on. So to work with step functions, you basically define your workflows in JSON. Then you visualize these workflows in the management console. And you can even monitor the current executions as well as audit previous executions there too. And you can see the execution history and the inputs and outputs of each of your state in your workflows. And there's different state types. So there's a task, which executes work. And then there's choices. So you can add branching logic. You can do things in parallel, and so on and so forth. So let's talk about types of deployments with CodePipeline and why you would choose to use step functions in them potentially. So if you have a simple deployment, for example, you don't have to worry about complex state management. Your whole pipeline can be done with either the existing pre-built integrations in CodePipeline or with Lambda custom actions. So you have to do something simple, or the data across your stages and actions can be entirely done through input and output artifacts. So meaning you can take the output of one stage in your CodePipeline and use that as the input in the next stage. Then I would say that's a simple deployment. However, if you need to do things like really customize what you're doing, so again, doing something like a load test where it's got a lot of steps involved, a lot of different things that you're executing. If you have to manage state across your pipeline, and if you have to marshal a lot of data across stages and actions, I would say that's a complex deployment. So for such a complex deployment, you have a few options. The simpler option is just to use a Lambda custom action. So all this does is literally it triggers a Lambda function in your code pipeline. This is great for doing things like triggering a third-party API, writing a value to a DynamoDB table, or automating manual approvals. So for example, you have a manual approval step in your code pipeline, and but instead of having to manually actually go and hit approve, you trigger a Lambda function that checks a bunch of, say, monitoring conditions, and if they're within an acceptable range, it hits approve on your pipeline. The maximum execution time for a Lambda custom action is 15 minutes, so that's something to keep in mind. Now, with a step functions action, this triggers a step function state machine. This is great for more complicated actions, which require orchestration, decision-making, and complex logic. This, for example, you can trigger a distributed load test. You can run an ECS task until some arbitrary condition is satisfied. If you need to read or write a lot of values to DynamoDB tables as atomic transactions, these are all examples of why you would use step functions. And another thing to keep in mind is, unlike the maximum 15-minute execution time for a Lambda custom action, with a step functions action, the maximum execution time is 365 days. So let's talk about some scenarios for orchestrating complex deployments. So this is actually how Amazon does their continuous delivery. So we've got the source code, and then the developer builds their source code, and then you go to pre-production. So we'll call this environment alpha. And so here you do automated tests, and then if those pass, you go to beta environment, then you do automated integration tests, performance tests, browser tests. Then you go to a gamma environment, you do more integration tests, you do some synthetic tests, and some API smoke tests. And then you go to your production deploy. And in the production deploy, you do it in a very granular kind of cell-based manner. So first you do a canary deploy to something like one of it. And then after the canary deploy, you deploy one availability zone. Then you deploy a second availability zone. And at any point, if you have anything that fails here, you stop the deployment. Then you go to a third availability zone. Then you do your synthetic monitoring based on that. Then you go to another region. Then you go to more regions. And you keep going. And so when we say source code, we mean the application code, the code for the infrastructure as code, so CloudFormation templates that define the environment, any kind of patching that's needed, any kind of configuration. And so that's how the process works at Amazon. So for some of these things, like for example, the automated load and performance tests, you might want to use a step functions state machine to do that. So let's take a look at how this works. So we've actually got in our solutions library, we've got a distributed load test solution on AWS. And the way that it works is there's essentially a step function state machine, and that triggers the load tests in AWS Fargate. So you've got an ECS cluster running in Fargate, and it's executing load tests as you need them to. So essentially, the load tests are executed. So on the left here, I've got the actual parameters for my load test. So this tells it to test my blog and with the method that it's using, and you can do a simple or a complicated test. So I'm just doing a simple test, so it's literally just hitting the home page of my blog, but you can give it a JMeter test file or a test plan. And then you also specify how many tasks you want and how much concurrency you want per task. So for example, in the demo that I'm about to show you, I'm gonna have 10 different tasks. So there's gonna be 10 ECS tasks that spin up, and each one of them is gonna have 10 virtual users in it. So there's gonna be 100 virtual users in my load test. And essentially when this all finishes, the chart on the left here, or on the right here, you can see it'll all run all the tests, collect all the results, and show those in a web console with the statistics for my load test. So to put it all together, this would be a sample pipeline that used this. So you've got your source code and code commit for your website. You then run some unit tests using code build. You then do a canary deploy using code deploy. You then do a staging deploy. And then you do your load test against the staging environment using this distributed load testing solution. And if that completes successfully, you then go on and do your production deploy. So when you configure the actual the stage and the action with the load test, you're going to choose step functions, and then in the step functions option, you just choose the state machine ARN, and you give it a parameter, so you tell it which test ID that you've already previously configured to execute, what the task count is, and what the test type is. And then it all goes ahead and executes and goes to production if everything worked well. So let's actually go ahead and take a look at my demo and see how that works.
For my demo today, I'm going to show you how to use a CodePipeline, which is set up to deploy a simple WordPress website and add a load test using step functions into that pipeline. So in my pipeline, we've got the source code, which is in a code commit repo. And then we've got a test action, which triggers a Jenkins instance that I have running and a test inside that Jenkins instance. Then if that passes, I'm doing a canary deployment. This is just a deployment using code deploy to one instance. So that way, if there's some kind of error that I've introduced into the deployment, I catch it really quickly instead of catching it later on when it's doing deploys to a bunch of instances. Then I've got my staging environment. And so the staging environment is deployed to using code deploy. This has an auto scaling group. It's much more similar to what exists in production. And this is where I've inserted the load test. So I've got a load testing stage here, and the action triggers a step function state machine. And that actually executes the load test. And if that's successful, then we go to my production deploy. So my production deploy, we've got a manual approval. So after the load test passes, or if it passes, I would then go ahead and approve this deployment. And that would then trigger the actual deployment in my production environment. So let's take a look at some of the other components here. So we've got my blog. This is what I'm actually deploying and updating the code for. This is just a standard WordPress website. It's using auto scaling groups and ALBs and CloudFront and RDS. So it's set up in a well-architected manner, but it's still at the end of the day WordPress. And for the load test, we're using this distributed load testing solution, which is on our solutions library. And basically the way that this works is you can set this all up with a CloudFormation template in a few minutes. And it's using Taurus, which is a load testing tool that's open source. And there's a web front end, and typically the front end triggers the load test, which is set up in step functions, and the step functions execution machine or state machine basically triggers tasks of Taurus that run in a Fargate cluster, and the number of tasks is defined by the user. Now, instead of using the web interface to start the load test, we're actually going to do that straight from my code pipeline. So this is the actual front end for my load test. And then we've got CloudFormation. This is, again, how I've set up the load testing framework. And if we go to outputs here, we can see this is the URL of that web console I was just in. And so let's trigger our actual deployment here and see what happens. So what I'm going to do is I'm going to go to the top of my pipeline, and I'm going to click on release change. And that's just going to redeploy the last update I made in Git. So I'm going to click on that, and then this is going to start the deployment. And as you can see, it's in progress. And we're going to actually wait until it gets through the test, the Jenkins test, the staging deploy, and the canary deploy. And when it gets to step functions, we'll resume, and I'll show you what happens then. Okay, so now my canary deploy and my staging deploy have finished. So this has kicked off my load test. Let's see what happens during the actual load test. So I'm going to click on the step functions action, and here is the execution status of my step function state machine. And we can see here that what it's actually doing is it's all graphed out here. So let's take a look here. And it's checking if there's current running tests, which there aren't. So then it goes and starts running these tasks. And let's see what happens when it does that. And it's going to wait a minute after it runs the tasks to see their status. So I'm going to actually go to my ECS cluster here. So this is my ECS cluster, but it's all in Fargate. And I'm going to hit refresh here. And so when I last hit refresh, there were 0 tasks running, and now there are 10 pending tasks. And so as soon as these are running, they're going to actually execute the load test. So let's wait until that happens and see what it looks like. Now the tasks are all running. And so let's see what it looks like inside one of these tasks. So I'm just going to click on the specific task, and then I'm going to go and click on view logs and CloudWatch logs. And then now we can see the full output of what's going on inside this task in near real-time conditions. So as you can see, if we scroll to the top, it's essentially started my load test. It spins up Taurus, which is, again, the open source tool it's using to do the load test, and it starts spinning up the 10 virtual users, which is what I specified. And it's going to wait and basically run the test for 2 minutes with 10 virtual users. And again, there's 10 tasks, 10 virtual users per task, so 100 total virtual users in this load test. So I'm going to hit refresh here, and we're going to see if it has completed or not yet. All right, so it's still running, so let's give it a minute to complete here and see what happens. All right, so let's refresh one more time here. Okay, so we can see here that the load test is actually completed. So we see the results, and we see that it's, there's been no errors against my blog, and we can see that it ultimately uploaded those results. So let's check back in on the state machine. So we can see here that now all the steps are done. So we've got the tasks have run, it's waited for a minute, it's checked the status of each task, and it's parsed the results. And so if we go back to my code pipeline, we should see it complete. Yep, there we go, it's changed to succeeded. So let's take a look at the actual output of the load test here. So I'm going to go to my load test console. I'm going to go to the dashboard. I'm going to click on my test as soon as this loads. And we can see that the test has been completed. And here we can see the statistics on the test. So this is the data that was uploaded at the end of each task run. We can see the average response time, latency, how many successes there were, how many errors there were, and we can see these metrics haven't filled in yet because the load test just happened, but we'll eventually be able to see the CloudWatch metrics on my test and the average percentile response times. So that's the load test. And so now that I've seen that's successful, what I can do here is I'm going to go to production. I'm going to go to my manual approval, and I'm going to say production deploy approved, load test looks good. And that's going to take me into my production deploy. So just to summarize, what we've done here is we've gone through a whole code pipeline execution where it deployed to multiple environments and triggered a load test. And sorry, that's actually my Slack notification that my production deploy instances are being spun up. But yeah, so let me just let those finish here. There we go. It's spinning up, I think, about 8 instances actually for the production deploy. But yeah, just to summarize, so we've gone through this whole pipeline. We've done a load test on my staging environment. That load test has succeeded, and that has allowed us to go to a full production deploy. So just an example of how you can use step functions in your code pipeline for doing complex deployments.
All right, so that's my demo. So now we're going to have some time for Q&A. And if you want to learn more, here's some good next steps. We've got a blog post on fine-grained continuous delivery with CodePipeline and step functions, and it has some more examples in it. We've got a tutorial in our documentation for CodePipeline on how to invoke step functions actions from a pipeline. We've also got some examples of step functions use case in the step functions documentation. And we've also got this distributed load test solution that I used for this demo, if you want to take a look at that. And we've also got the Amazon Builders library, which is articles and videos on how Amazon builds and operates the technology that underpin both AWS and Amazon.com. And so it's basically our lessons learned and best practices documents there. So those are good places to start if you want to learn more on how to do CI/CD with complex deployment scenarios. So thank you all for coming. It's been a pleasure. And please remember to complete your session survey. Thanks.